in this question, we have to solve the equation given to us in the given domain. Okay, now the question is 2 cos square theta is equals to 3 sine theta. What we can do is we can replace the cos square theta with 1 minus sine square theta, because we know there's a trigonometric identity which is sine square plus cos square equals 1, which gives cos square equals 1 minus sine square. Okay, now I'm going to expand and rearrange this. I'll have 2 sine square theta plus 3 sine theta minus 2. Okay. This is a hidden quadratic equation. We can solve this using middle term breaking. I'm going to directly do it. Instead of assuming let sine theta is equals to y. Okay, so it's going to be 4 and minus 1, the factors for middle term breaking. Okay, now I'm going to take 2 and sine theta common here, which gives me sine theta plus 2. And here we can take -1 common, which gives us sine theta plus 2 again. So we have sine theta plus 2 in one bracket and 2 sine theta minus 1 in the other, which gives us sine theta is equals to -2. And sine theta is equals to half. Okay. This is not possible because we know that the graph of sine has a range between 1 and -1. So you write no real solution with this one. There's no way sine theta graph can have a value of -1. No real solution. Here we're going to find the absolute angle first, which is sine inverse half, which is 30 degrees. And we plot it in the first and the second quadrant where sine is positive. So we're getting two answers within the given domain, which is 0 to 360. One of the answers is theta is equals to 30, and the other answer is theta is equals to 150. We got 30 and 150 as answers for part 1. Let's do part 2 now. Part 2 says the smallest positive solution of this equation where n is positive is 10 degrees. Okay. So look at these two equations. They're pretty much identical except for okay. So back to the question. Okay, so looking at these two equations, they are similar except for this theta gets replaced with n theta. That means we will still get the same solutions 30 and 150 by solving this equation, the second equation, but we'll write n theta equals 30 or n theta is equals to 150. We need the smallest possible solution, or they're talking about the smallest possible solution that we'll get from here, the smaller value, 30. And the solution is given, which is 10 degrees. Solution is the value of the variable, which is theta. So we know that theta is 10. So n times 10 equals 30. So n will be 3. Okay. State the value of n, and hence means you have to use this previous answer. Find the largest solution of this equation. All right, let's look at this equation, and we need its domain so that we can figure out the largest possible answer in the domain. Okay, so this equation is 2 cos square 3 theta equals 3 sine 3 theta. So the domain is not going to stay the same, which is 0 to 360 degree. This is now a transformed trigonometric equation. Look, we have 3 theta here. So we'll have to fix that. These two need to be the same. So I'm going to use the technique taught in class that let y is equals to 3 theta. So this becomes y. And I have to write this in terms of y as well. So we can write theta is equals to y upon 3, 0, y upon 3 here, 360 degree here. Now we multiply 3 on all sides, we get 0, we get y, and we get 1080. Okay. Now the solution of this is going to be the same as solution of this. We got two solutions, y equals 30 and y equals 150. Okay, but the domain is pretty big. The domain goes from 0 to 1080. So we can keep adding 360 degree to these answers till we get the highest value, which is just smaller than 1080. So why are we adding 360? Because that is the period of sine graph. And we got our solutions of part 1 by solving a trigonometric equation, which was in terms of sine. So that's why we're adding 360 to get the highest possible value. Okay, so when I add 360 to 150, I get 510. When I add 360 again, I get 870. And then when I add 360 again, that goes out of the domain. Okay, so the highest value that y is giving us is 870. That's the highest possible value of y we can get in the given domain. Now we're going to use this to get theta. Theta is y upon 3. So the highest value of theta we're getting is 870 upon 3, which is 290. That is the biggest value of theta possible in the given domain.